Hi everyone, welcome to my video. Today I'm going to show how do we evaluate the step response of a closed loop system in their steady state response. Please watch my previous video if you are interested to know how do we evaluate the transient of a closed loop system. So let's begin with the example A with the forward transfer function 0.5 over s plus 2, and I'm going to use the Filer value theorem to find out what is the steady state error. First, we will find what is a closed loop transfer function Ts, which we can get from what Gs over 1 plus GHS, which will give us 0.5 over s plus 2.5. And we can find out what will be our output Ys by multiplying Rs, which is our input, times Ts. 1 over s times 0.5 s plus 2.5. And then I'm going to shape this into this partial fractions form, which we are going to get 0.2s minus 0.2 over s plus 2.5. And if you were to get what is the t approaches infinity for our output, it will be equivalent to limit s goes to 0 s ys, which is limit s goes to 0 s 0.2s 0.2 divided by s plus 2.5, which eventually will give us 0.2. And then from here, we will be able to know that my steady state error based on this final output, okay, at time equals to infinity, my steady state error will be equals to 1 minus 0.2 divided by 1, which is 0.8, or we can say is the 80% error. Okay, so let's move to the second example. Gs equals to 4s multiply s plus 5. And this example, I'm going to use a different approach by applying a formula. Firstly, the formula requires us to find out what is our static positional error constant, Kp, which is equals to limit s goes to 0, Gs. And in this case here, very obviously, after substitution, we can know that my Kp will be infinity. And my steady state error will be A divided by 1 plus Kp, where A it is the magnitude of the step input. And in this case, since we are using unit step input, hence A will be equals to 1. But regardless of what value of A, if we use 1 over 1 plus infinity, we will get 0%. So in this case here, for part B, regardless of the magnitude of the step input, we are always going to get the result as no steady state error. Okay, so for part C, I'm going to use a simpler method by evaluating the system types. If you look at GS and we extract all the pure integrated term s in front, and then this will tell us the system type. And in this case here, this is actually the system of type 1. And system of type 1 will always end up with steady state error equals to 0%. And this is only for step input. Okay, so that's all that I want to show in this video. Thank you for watching. Bye.